Plate boundary animations. Objective 1. I can identify the geologic features and events formed at each type of plate boundary, convergent, divergent, and transform fault. Before we can discuss the plate boundaries, we need to discuss what is the plate made of. Well, the plates, as we call them, are made of the lithosphere, and the lithosphere is part of the crust but also part of the upper mantle. It's a hard, rocky layer, and below the lithospheric plate is the asthenosphere, which actually allows the plates to move because the asthenosphere moves in the circular motion. And so when it's moving this way, it actually moves the plate in the leftward or the westward direction. The asthenosphere over here is actually moving to the right or eastward, and it allows this plate to move right or eastward. The asthenosphere over here is moving to the left in a circular motion, and so it allows that plate to move to the left. And over here, the asthenosphere is moving to the right, which makes this lithospheric plate move to the right. Convergent plate boundaries are where the two lithospheric plates move toward each other or collide. And it's all because the asthenosphere, remember, is moving in that circular motion, forcing those rocky plates that are floating on top to hit each other. And because of that, certain geological features and events are created. The next is the divergent plate boundary, and yet again it has to do with the lithospheric plates, but instead of colliding like with the convergent plate boundaries, the divergent plate boundaries are where the plates divide or separate from each other. And yet again, it's because that asthenosphere is moving in a circular motion, forcing those plates that are floating on top to move, in this case, away from each other. The last plate boundary we're going to talk about is the transform fault plate boundary. Yet again, it's those rocky lithospheric plates, and in this case, they're not moving away from each other, they're not moving toward each other. In this case, they're grinding past each other. Literally, it's kind of like you're sliding your hands when you press really hard. You try to move one farther forward than the other. All right? In this case, guess what? It's because of that asthenosphere moving in that circular motion that's causing these plates that are floating on top of the asthenosphere made of rock to grind past each other. Now we're going to discuss the difference between geologic features and geologic events. You eventually, after I'm done discussing this, will copy this into your workbook on page 2. So on the left, you see geologic features. So the way I remember geologic features is they're types of landforms. So mountains and mid-ocean ridges. Mid-ocean ridges are chains of mountains, and obviously in the ocean. Volcanoes, islands, and remember islands can be mountains, and islands can also be volcanoes. We have different ways to say the word valleys. So obviously valleys that happen on the continental crust. Then we have rifts, which are valleys that occur at divergent plate boundaries. And then we have trenches, which are very deep valleys that occur at convergent boundaries. Then we have faults, which occur at transform fault boundaries, and we'll get into that later at the discussion station with Mrs. Colville. And then we have rivers and riverbeds, which usually occur at transform fault boundaries. Now on the right, you see geologic events. Now the way I think of it is it's unpreventable or unpredictable events. So obviously a volcanic eruption or earthquakes. Now the last one, tsunamis, we can prevent because they occur based on earthquakes, but we're not given a whole lot of time or warning. So now I want you to make sure you open up your workbook to page 2. Click pause. You're going to copy these notes. When you're done, continue with the video. The next part, you're going to need to open up your workbook to page 110, and you're going to take notes on what geologic features and events you can identify from this simulation or animation of the plate boundaries. Like always, be sure to hit pause so you can identify all the geologic features or events, or hit rewind if you need to re-watch any of them. Here you're going to watch an animation or simulation of convergent plate boundaries where the plates are colliding. Be sure to notice the movement of the asthenosphere, how it's moving in a circular motion so that the two lithospheric plates collide. Use your legend to identify what geologic features or events are formed within the lithosphere and even on top of the crust. Click pause at any moment. The next one we're going to look at is when two oceanic plates converge or collide. All right, and this is also needs to be taken in your notes. Notice the asthenosphere here is also moving in a circular motion. And notice what's occurring on the lithospheric plates in within the ocean and the oceanic crust. What geologic features and events are being formed. Please make sure you identify all of them in your workbook. Now this animation is for the divergent plate boundaries. I want you to pay attention yet again to that asthenosphere and the movement that it has on how it moves those lithospheric plates away from each other, or they're diverging from each other. Identify what geologic features and events are formed within the lithosphere and on the crust. All right, click pause at any time that you need to. Use the legend, use this key to help you complete your notes. Last but not least is the transform fault boundary. So I want you yet again to look at how these two lithospheric plates are moving. This lithospheric plate on the right is moving northward, while this lithospheric plate on the left is moving southward. All right, identify the geologic features and events that are forming where these two plates are grinding past each other. Notice there is no space between the two plates. All right, now we're going to look at how transform plate boundaries can also be bent. So notice this curved line between the two lithospheric plates. All right, so the plate on the right is moving northward, while the plate on the left is moving southward. All right, notice along this bend or bent, the geologic features and events that are being formed. All right, be sure to use your key to help you fill out your notes. And look at that, look at those mountains. I wonder how those mountains got so high. And here's one last transform fault boundary that's bent. So notice the plate on the right is moving southward this time, and the plate on the left is moving northward. Notice this gap that's being exposed. All right, notice what's filling it up. I bet we'll have a discussion about that. Use your legend to identify what geologic features and events are being formed by this transform fault boundary. Remember, if you need any assistance with your notes, rewind and rewatch the video, and I cannot wait to talk with you during discussion. Now that you've taken your notes, you need to submit on Schoology at this station an assignment. So number 1, you need to identify 3 geologic features or events you learned about from this video. Then tell me for each geologic feature or event where in the world, a real location, you'd find each feature or event. So here's an example that you may not use in your answer. You would find a canyon, which is a geologic feature, in Arizona, a specific location in the world. So make sure when you're telling me for your 3 geologic features or events, you tell me exactly where I could find it in the world.